up until this point, I've always told you that we can't take the square root of -1. And today I'm going to tell you that that's not exactly true. We actually can take the square root of -1. And when we do that, we call the answer I an imaginary number. Imaginary numbers are also called complex numbers. For a complex number, there will be two parts. You'll have a real part and an imaginary part, usually written together as a plus sign. So the real part here is the A, the imaginary part is the BI, and the definition of I is the square root of -1. We can do all kinds of operations with complex numbers. For example, we can add them and subtract them. In order to add and subtract, you just need to treat them as if they were like terms. So here we're going to add the 5 and the 6 to get 11. And then we'll add the 1i with the -2i to get -1i. Or if you prefer, you can just write it 11 minus I. For number 2, we need to distribute the negative sign. That will give us 3 plus 2i minus 6 minus 13i. 3 minus 6 is -3. 2i minus 13i is -11i. Number 3, we are multiplying the complex numbers. This is just like multiplying variables. You end up with -3i squared, because I times I is I squared. The only difference here is that we have to change the I squared. Remember we said earlier that I is the square root of -1. Well, if we square both sides of that equation, then I squared is equal to -1. So anytime you have an I squared, you need to replace it with a -1. Then -3 times -1 is a +3. Number 4, 2 minus I times 4 plus 3i. Here we're going to FOIL. 2 times 4 is 8. 2 times 3i is 6i. -I times 4 is -4i. -I times 3i is -3i squared. Now I'm going to rewrite this as 8 plus 2i minus 3 times -1. So 6i minus 4i is 2i. I squared is -1. And now we have 8 plus 2i plus 3, and then finally 11 plus 2i. You always want the imaginary part second. That's just standard form for a complex number, a plus bi form. Number 5, 3 plus 2i quantity squared. Let's go ahead and write that 2 times. 3 plus 2i times 3 plus 2i. And then FOIL it. 3 times 3 is 9. 3 times 2i is 6i. 3 times 2i is 6i. And 2i times 2i is 4i squared. 9 plus 12i plus 4, and then replace the I squared with -1. Then 9 plus 12i minus 4. 9 minus 4 is 5. So we end up with 5 plus 12i. Okay, for the next problem, we have to be careful because of the negatives underneath the radical. We have to get those negatives outside before we can multiply underneath. So in other words, we need to rewrite this as I times the square root of 5, and then I times the square root of 10. Those negatives underneath come outside of the radical as an I, because the square root of a -1 is I. Now you can multiply. I times I is I squared. Radical 5 times radical 10 is radical 50. I squared is negative 1. Radical 50 is 25 times 2. So we end up with negative 1 times 5 radical 2, which is negative 5 radical 2. Number 7. Again, we need to take the I outside to get the negative out from underneath the radical. Then we need to simplify those radicals. 128 is 64 times 2. And radical 50, again, is 25 times 2. So we're going to end up with 8i radical 2 minus 5i radical 2, and that simplifies to 3i radical 2. One over 1 plus I. Just like we don't like radicals in the denominator, we cannot have i's in the denominator. So we're going to multiply by the conjugate. The conjugate of the denominator is the same expression except you change the sign of the I. So this will be 1 minus I over 1 minus I for the conjugate. In the numerator, 1 times 1 minus I is just 1 minus I. In the denominator, we're going to have to FOIL. So if it helps you, go ahead and put parentheses around both expressions. And then 1 times 1 is 1. 1 times negative I is negative I. Positive I times 1 is positive I. And then I times negative I is negative I squared. The numerator is going to stay just the same, 1 minus I. And then in the denominator, negative I and positive I is 0. So we have 1 minus, but then I squared gets replaced with negative 1. So now the problem is 1 minus I over 1 plus 1, which is 1 minus I over 2. We're actually still not done yet because we need this to be in the proper form a plus bi. So to do that, separate the fractions. Make it 1 over 2 minus 1 half I. So now it's the a plus bi form. Let's do another one. This time the conjugate of the denominator will be 4 plus 2i. We just change the sign of the imaginary part. Multiply the numerator and the denominator both by the same thing. I'm going to make parentheses here. And then let's FOIL. 2 times 4 is 8. 2 times 2i is 4i. 3i times 4 is 12i. And 3i times 2i is 6i squared. In the denominator, 4 times 4 is 16, plus 8i, minus 8i, minus 4i squared. Back to the numerator. 8 plus 4i plus 12i is 16i, plus 6, and then replace the I squared with a negative 1. In the denominator, 8i and negative 8i are 0. So it's 16 minus 4, and then replace the I squared with negative 1. Back to the numerator, 8 plus negative 6 is 2. And the denominator, 16 plus 4 is 20. Separate the two fractions. 2 over 20 plus 16 over 20i, and then simplify. 1/10 plus 8/10, actually that can be simplified even more. 4 goes into 16 4 times, and 4 goes into 20 5 times. So 1/10 plus 4/5 I. For this problem, we're going to need common denominators. So let's multiply the first term by 2 minus I, and multiply the second term by 2 plus I. Distribute the 2i, 4i minus 2i squared, and then distribute the 5, 10 plus 5i. In the denominator, go ahead and distribute. 2 times 2 is 4. 2 times I is 2i. Negative I times 2 is negative 2i. And negative I times I is negative I squared. Now we need to clean this up. In the numerator, 4i plus 5i is 9i. Minus 2, change the I squared to a negative 1, and then plus 10. In the denominator, 2i minus 2i is 0. We have 4 minus, change the I squared to negative 1. Back to the numerator, 9i plus 2 plus 10, and then in the denominator, 4 plus 1 is going to be 5. So this is going to be 14 plus 9i over 5. Separate it, 14 over 5 plus 9 over 5i. Use the quadratic formula to solve the quadratic equation. A is equal to 1, B is equal to negative 2, C is equal to 2. The quadratic equation is x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. And so we make the substitutions. X equals 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 2, whole thing over 2 times 1. X equals 2 plus or minus the square root of 4 minus 8 over 2. So it's 2 plus or minus the square root of negative 4 over 2. That's going to be 2 plus or minus I times the square root of 4, which is going to be 2 plus or minus 2i over 2. Separate the fractions. 2 over 2 plus or minus 2 over 2i. So finally x is 1 plus or minus 1i. You can leave it that way, or you can write it separately, 1 plus I and 1 minus I. Either way is fine.